Bam. Okay. So everything we've been doing up to this point in our math career has been defined as explicit mathematics, right? So I wouldn't go to say explicit mathematics, but what we've dealt with have been explicit functions, such as y equals x, f of x equals x, where y is defined as a function of x. These are the functions that we're always used to. Y equals, y equals, y equals. These are called explicit functions. So now we have something called implicit functions, where the function or the equation is implicitly defined in terms of y and x, meaning that you don't have y equals anymore. So the implicit equation would look like this: 3x squared plus y minus 2, basically where x and y are on the same side. So this would be an implicitly defined equation or an implicitly defined function. So the reason we have implicit differentiation is because the function that we take the derivative of, we do not have to rearrange it to solve for y. So implicit derivatives actually make the derivative process a lot easier, because it could make the process simpler, and it could avoid using some rules such as chain rule. So implicit derivatives were there to make our lives easier. We do not have to rearrange. All we have to do is take the derivative of both sides of the equation with respect to x, as you see here. So here's our implicit equation. We apply the derivative with respect to x on both sides, and then we apply the derivative to every single term, and then we just take the derivative. So the derivative of 3x squared is 6x. The derivative of y with respect to x is going to be y prime, and of course the derivative of 2 is 0. Now, after you take the implicit derivative, your main goal here is to solve for y prime. So when we take implicit derivative, after we take the derivative, the next thing we're going to do is solve for y prime. And once we get into the problems, I think the second problem, I'm going to show you why implicit derivatives make our life easy. But before moving on, I'm going to make a lovely little key here, because the notations I use and my math lab use are going to be a little different. So for implicit derivatives, if you have d over dx of y, then the implicit derivative is going to be noted as dy over dx. But for our lecture, to make the notation simpler, I'm just going to say y prime. Okay, so what I'm saying here is that dy over dx is the same as y prime. So whenever you see those notations, don't be confused. They mean the same thing. Okay, now let's say we did d over dx of y squared. Then this would become 2y dy over dx, or 2y y prime. And then let's do it again. Let's just say to the third power, d over dx of y cubed would be 3y squared dy over dx, or 3y squared y prime. Okay. And then for any other power, y to the n, you'd get n times y to the n minus 1 dy over dx, or n times y to the n minus 1 y prime. Okay, so all of this is the MML notation. But like I said, to keep the notation simple, this is what we're going to use today. We're just going to be y priming it. So this is what we'll use. Okay. And of course, I had it down below as well, the implicit derivatives. the implicit derivative of y is y prime, implicit derivative of y squared, 2y prime, and implicit derivative of y cubed, 3y squared y prime, and so on, and so on, and so on. Okay, so just reference that lovely little legend or key, so when we move on with our derivatives, it'll be a lot easier to look at. Okay, so let's go ahead and get started. We want to take the implicit derivative of 5x cubed minus y equal to 1. And then after we take the implicit derivative and solve for y prime, we're going to plug in 2, 4. Okay, so to get this started, we say d over dx of 5x cubed minus y equal to d over dx of 1. And now the derivative of 5x cubed is 15x squared. And the implicit derivative of y is going to be y prime. And the derivative of 1 is 0. Okay. Now, once again, after you do the implicit derivative, we want to solve for y prime. So fair enough, I'm just going to add it to the right side. And we get 15x squared equal to y prime. There's our implicit derivative. And now what we're going to do is evaluate it at the point 2, 4. So the way that notation works is we're going to say y prime evaluated at the point 2, 4. And now remember, a point is given as x and y. Well, we see for our implicit derivative, we only have an x value. So that means we are only going to plug in for that x value. So this means you'll get 15 times 2 squared, which gives me 15 times 4, which gives me 60. And that's it. So any questions on that process?
Quick question. Why don't we solve for y in that on that last deal?
Oh, for this part? If you're talking about the evaluation part, the reason we don't plug in a y is because we don't have a y. So let's say my implicit derivative ended up being y prime equal 15x plus y. Then we would plug in 2 for x and 4 for y.
Gotcha.
But since there's no y, we only plug in for x. Okay. All right, let's try another one. All right, y squared plus x cubed equals -4. Again, we'll say d over dx of y squared plus x cubed equal to d over dx of -4. So we apply the derivative to both sides. Okay. Well, the implicit derivative of y squared from that above legend that I wrote is going to be 2y, y prime, plus the derivative of x cubed is 3x squared equal to 0. There we go. There's the implicit derivative. And now, once again, our goal is to solve for y prime. So this means I'm going to take 3x squared, move it over to the right side, and I will be left with 2y prime equal to -3x squared. And then to solve for y prime, I'm just going to divide by 2y. and we get y prime equal to negative 3x squared over 2y. And there's our implicit derivative. All right. And now we evaluate it. And we're going to say y prime evaluated at the point negative 5, 4. And now this time, we actually have an x value and a y value we can plug in. So you're going to get negative 3 times negative 5 squared over 2 times 4. And negative 3 times 25, that's negative 75 over 8. There we go. All right. Any questions on that one?
Whenever it's like y to the second power, that's when you do the y and then y prime, right?
Exactly. So y squared is going to be 2y, y prime.
Okay, and then whenever it's like y cubed, is it going to be the other one that's 3y to the second power y prime?
Exactly.
And so on.
And so on and so on. So yeah, again, just reference what I wrote up there and it'll help you out.
Okay, sweet.
If you want to have the dy over dx's in there, do it. The reason I don't do it is it just looks messier.
Agreed.
Okay. So again, the reason implicit was created was to make our life easier and derivatives easier. Let's say we didn't know about implicit and we said, take the derivative of this function. Well, in order to take the derivative of it, you would have to solve it for y. So that means I would make it y squared equal to negative x cubed minus 4. And then in order to solve for y, I would have to square root both sides, which means I would get y equals the square root of negative x cubed minus 4. And now what we have just done is taken implicit form and put it into explicit form, the form that we know. And now we take the derivative of it, but first we would have to rewrite it as negative x cubed minus 4 to the 1/2, which means if you take the derivative of that, you'll get 1/2 times negative x cubed minus 4 to the negative 1/2 times the derivative of the inside. Meaning that this would become, if I rewrote everything, it would become negative 3x squared over 2 times negative x cubed minus 4 to the 1/2. Now, tell me which one looks easier, the one I just did or the implicit?
The first one.
The first one. That's why implicit was created, so we don't make our lives miserable with this. And believe it or not, this answer and this answer are equivalent. Because what I did here was say, hey, guess what? This y value is the same as that. Plah. Crazy, right? So this is why implicit differentiation was made, to make a derivative a lot simpler. I mean, if you like this way, cool. It's just a lot more work. Okay, let's keep going. All right, number 3, do it again. And say, apply d over dx to both sides. And now take the implicit derivative of the left side, the implicit derivative of y squared, is going to be 2y, y prime, minus the implicit derivative of y, which is just y prime, equal to 4. Okay, there it is. Implicit derivative is done. And now our job is to solve for y prime. So since we have two y primes on the left, that becomes a greatest common factor, which means we can factor out a y prime. And that will leave me with 2y minus 1 equal to 4. And then to solve for y prime, we just have to divide by 2y minus 1.
Can you explain the 2y? How'd you get that -1 in there?
Because what did I factor out?
The y prime.
The y prime. So what's anything factored from itself?
1.
1. There you go. Okay. And then we end up with y prime is equal to 4 over 2y minus 1. And there's our implicit derivative. And now we just have to evaluate it at the point 3, 5. Now, do I have any x's on this implicit?
No.
Yes. Oh,
No.
actually, no.
No x's, which means we don't have to plug in 3. The only thing we have to do here is plug in 5. And that'll be 4 over 10 minus 1, so 4 over 9. There you go. All right. Any
That
questions on
part-
that?
The only part that kind of confused me, I mean, going back to what Chris was saying on the 2y minus 1, how like to get to that, just because both y primes are on the same side. Is there ever going to be a time where the y prime is on the opposite side of the equal sign?
It could be, and then you would have to bring it over to combine them.
Okay, so you would just change if it's a negative to a positive and vice versa.
Exactly. Like let's say it was 2y y prime equal to 4 plus y prime.
Yeah.
You would have to bring this over to that side. Meaning you get the 2y prime minus y prime equals 4.
And then what do you do from there?
And then from there, you look for a greatest common factor. So what looks common on this side?
It'd be the y prime, even
The
though
y
one's
prime.
a negative and one's a positive.
Yeah. So remember, being a common factor nothing matters about the sign.
Okay.
As long as it's a common factor, right?
Okay.
So that's why when you factor out the y prime, you'd be left with the 2y minus 1. And remember, to make sure you factored correctly, to check your work, just distribute it back in. What's y prime times 2y?
2y y prime.
And what's y prime times 1? Or -1?
Yeah, it'd be negative y prime.
There it is.
Okay, interesting.
So it would be the same as if I said, hey, I have 2x squared minus x. What's my greatest common factor here?
It'd be the x.
So if I factor out an x, what would I be left with?
2x minus 1.
2x minus 1. Same concept.
Oh my gosh. Okay.
Same concept, just different letters and notations, right?
Yeah.
It's that algebra. Okay, let's keep moving then. All right, 4. 3xy minus 2x equal to 2. So let's go ahead and take the implicit derivative with respect to x on both sides. And then here we're going to have to take a moment to pause because this 3xy, since it's implicitly defined, this means that x and y are their own functions, which means that if you have x times y, we have to introduce what rule? What is the rule we have when two functions are multiplying each other? And we want to take the derivative of them.
You add them?
I'm talking more of a sense in derivatives.
The implicit product.
Implicit product rule. Remember our product rule? You use product rule if you have one function times another, right? So in this case, since it's implicitly defined, x is one function and y is the other function, which means in order to take the derivative of this equation, we have to do an implicit product rule. Oh, everything comes back, right? So I'm going to say implicit product rule of x times y. And don't worry, that 3 will come back in later. So remember how product rule works. So this means that f will be x and g will be y. Well, the derivative of x is 1. And what is the implicit derivative of y?
Y prime.
Y prime. Okay.
Holy cow.
Let's continue this. So the 3 will come down. And now inside, let's follow our product rule. F prime g will give me y plus g prime f, y prime times x, which I'm going to just write as x, y prime. There it is, guys. I mean, we're not done yet, but we're done with that implicit product rule. So to save you some time, if you ever see x times y and you are taking the implicit derivative, just know that the implicit product rule of x times y is going to be y plus x, y prime. So save that somewhere in case you see it again, like on your homework. You're like, oh, that's just y plus x, y prime, and save yourself like 10 seconds. Okay, moving on. We now have the implicit product rule derivative of x times y, which means we continue on and take the derivative of negative 2x, which is negative 2, and the derivative of 2 is just 0. Okay. Implicit derivative is done. So now we solve for y prime, but in order to do that, we have to distribute that 3. So we'll get 3y plus 3xy prime minus the 2 equal to 0. Now to solve for y prime, move everything over that doesn't have a y prime. So that means I'd be left with 3xy prime equal to 2 minus 3y. Or if you wrote it as negative 3y plus 2, that's fine as well. And then to solve for y prime, what would I divide by?
Three.
3xy prime.
Just 3.
Oh, 3x.
Because we're solving for y prime. And you'd get 2 minus 3y over 3x. And there's your implicit derivative.
I have a question.
What's up?
How did you get to the 3xy prime equals 2 minus 3y. You were saying to move everything over that doesn't what?
That doesn't have a y prime.
Okay. So what you did is that you added 2 to both sides and then you subtracted 3y to both. I mean, yeah, to both
Exactly.
sides.
Exactly.
Okay. Got you. That's what I was kind of confused
Cool.
about.
There
Sorry.
you go.
And
You're good.
then the next thing that I just wanted to kind of say, it's not really a question, but what kind of tip, I guess, could you give us? Because I think one of what I have most difficulty with is knowing like what to use when we're taking tests, like whether it's, the product rule or whatever kind of rule we're going to use. What kind of tip could you give us so we know what to use?
Well, I mean, it's kind of in the name, right? Product means that your functions are multiplying each other, right? So if you have, let's say if it was like 3x squared times y to the third, since these two are multiplying each other, that'd be product rule. And like I said, it's all in the name. Let's say if it was 3x squared over y cubed, then what rule would that be?
The quotient?
That would be quotient, right? And like I said, it's all in the name. Quotient means fraction.
Yeah.
Right? Okay. And then chain rule, well, chain rule is if you have a composition function, such as, let's say if it was if it was parentheses, 3x plus 1 to the third. Then if you see something like that, that's definitely chain rule.
Okay.
So anything like that. But basically the name gives it away. Product rule means your functions are multiplying each other. Quotient rule means your functions are dividing each other. And chain rule means it's a function made of multiple functions. So if you have a function inside the parentheses raised to another power, that would be the chain rule. Okay. 2 minus 3 times 3 over 3 times 1. And that would be 2 minus 9, which is negative 7 over 3. There we go. All right. Any questions on that one before moving on? Okay. All right. Let's do it again. All right, number 5. X squared y minus x cubed equal to negative 5. So again, let's start it. We'll say d, oh boy. No. Okay, good. Thought my laptop was acting up. D over dx. Oh, it is. That's weird. X squared y minus x cubed equal to d over dx of negative 5. Okay. Well, once again, what are we going to have to do on x squared y?
Yeah, we're gonna have to do the product.
Yeah, another implicit product rule.
Yeah.
Implicit product rule of x squared y. Okay, so this means again, f will be x squared, g will be y, derivative of f is 2x, and implicit derivative of y is always
Y prime.
y prime. There we go. Which means let's go ahead and continue. Follow your product rule. F prime g. I'll say continuing here, 2x y. plus g prime f. So y prime times x squared, but I like to write it with the x squared first. So we'll say x squared y prime.
Why is that?
Just, I don't like the way it looks when I say y prime x squared.
Okay.
It's just the way things look. But if you like the way that looks, that's fine. Okay, so there's the implicit product rule. It's done. I guess let me save that up here. Hang on. In case you ever come across it, save yourself some time. There we go. We have another implicit product rule formula. And now let's continue. Now we're at the derivative of negative x cubed, which is negative 3x squared equal to 0. Okay. And now, once again, solve for y prime. So what terms are you going to move over?
Everything besides y prime.
Everything besides y prime. That works. So you get x squared y prime equal to positive 3x squared minus 2xy. And then divide by x squared. So y prime will be 3x squared minus 2xy over x squared. And now for this one, we actually have a chance to simplify more because in the numerator, you have a greatest common factor of what?
X squared.
Well, just
X.
x. Because then you'll get 3x minus 2y over x squared, where cancel, cancel, and that power becomes a 1, which means we get our implicit derivative as 3x minus 2y over x. Okay, there it is. And now we just have to evaluate y prime evaluated at the point 2, 4. So 3 times 2 minus 2 times 4 over 2. And you'll get 6 minus 8, which is negative 2 over 2, which gives us negative 1. Okay. Any questions on that one?
I'm glad we have homework to practice.
Right? That's what homework is. If you see homework as practice, then it was never homework at all.
Wow.
Right? Mind blowing, right? Okay. Let's move on then. All right. Number 6. The demand X is the number of items that can be sold at a price P. For X equals P squared minus 4P plus 1200, find the rate of change of P with respect to X by differentiating implicitly. Okay, so all we're going to do here is solve for P prime. This is what it's asking. It says find the rate of change of P. So we're looking for P prime. So that means we're going to take this equation and apply implicit differentiation to it. So here we go. We'll say d over dx of x equal to d over dx of p squared minus 4p plus 1200. Okay, and you'll treat p as if you were treating y with implicit derivative. So when we take the derivative of x, we get 1. And then we're going to take the implicit derivative of p squared. So that's going to give me 2p p prime minus the implicit derivative of 4p, which is just 4p prime. And then the derivative of 1200, well, that is just 0. Okay, so here's our implicit derivative, and now we must solve for p prime. So what could you do on the right side?
Factor.
Good. Factor out a p prime, and you'd get p prime times 2p minus 4. And then to solve for p prime, you would just divide by what?
2p minus 4.
That's it. And 1 over 2p minus 4 is equal to p prime. And that's it. That equation would be the rate of change of p. So that would give you the rate of change of price.
Is class done?
And I guess that's it. For sure.
Nice.
Yeah. And that's it, guys. That is implicit differentiation. So if you got questions, stick around.
All
Other
right.
than that, we're done.
Have a good evening.